Good afternoon. My name is Bastiaan Bijl. I'm here together with Mohammed Al-Amini, and we came from the company Coentunnel, and I'm going to present something that we built for the Coentunnel, a tunnel in Amsterdam, because we used Virtuoso database for our application. And actually, I'm not really sure if what we did is uncommon. I expect that all of you are really familiar with RDF and triples, etc. But I have to see how quickly you can follow the pictures that I made. A year ago, around May, we were asked to make a system for the Coentunnel, which is called the Performance Measurement System, the PMS. And I will explain what it does and how we use the Virtuoso database for that. So first, the architecture. This is the Coentunnel in Amsterdam. It's the second one, the newly built one. And this is the Virtuoso database, and we call it the quad store. And what we do, there's sensor data from the tunnel called OPC data, which is stored in the database. That's one source, and there's another source from Relatix. Relatix is a system where a lot of semantic data is stored. And in this architecture, it is used to contain manual inspections of the tunnel. And the result of the system is that it makes a quarterly exploitation invoice. And the purpose of that is that every quarter the Netherlands, or the state of the Netherlands, pays for the uses of the tunnel, but the tunnel has to perform. So, for example, something went wrong some days ago, so maybe some of you have seen it in the news too. The system, a part of the system went down here, before the sensor data system. And then they had to close the whole tunnel because the cameras weren't seeing what was happening. So the tunnel didn't perform for about 4 hours. So what happens then is that there's a fine on the invoice. So the amount of money paid every quarter is less. So the company CCI, which is responsible for the exploitation, really has is really pressed to make the quality of the tunnel really good, because otherwise they get less money every quarter. So we were asked to build a system that can produce such an invoice based on the data that is coming from the sensor data and from the semantical Relatix platform. I will now show how it's deployed. So this is the servers that are used inside the Coentunnel, but I also have a different picture of that. Try to show that really quickly. I'm not sure if you really are interested in that, but I like the picture. So this is our website, and we have this story here. This is a picture. So these are the real servers. And I try to copy that here. So what do we have? We have two Windows 7 servers that collect the OPC data, so the measured data. We have two Windows servers where Relatix runs on, and this is interesting. Here we have two Ubuntu servers running Virtuoso database. I can show what it does. The two OPC servers have a queue, and messages from all the sensors in the tunnel are pushed there. And Relatix has a soap endpoint, so that was there already. And then our system came. We have two Virtuoso databases, and then this is our first application. The Relatix client grabs data from the soap endpoint and stores it in the Virtuoso quad store. And we have our second application, the OPC client, gets data from the queues, OPC queues, stores it in the Virtuoso database, and then this virtuoso database is replicated to the second one. So this is how it, what processes are involved. And the final application we made is the admin interface. We called it the PMS admin interface. And I will now go into that interface to show you actually how our data model is constructed. Because I think that's the most important, or most interesting part of our system. And please let me know if there's, I think it's actually really simple what we made, but there's a lot of things to be seen. So please let me know if at some point it's unclear. This is how the admin interface works, or looks like. So it's a website, and you can enter there when you're at the Coentunnel site, not from outside. This is just pictures. So I'll zoom into it. What I opened is one data instance, and this is an instance of the CCI company. So this whole object represents kind of, you could see it as a semantic web resource. And it's in the PMSE namespace. So this is the namespace pms.coentunnel.nl/instance. And we also have classes, which is, we have one printed here, class organization, and that's in the PMS namespace. So that's our separation. We have instances and classes, and the set you see in the left is a set of all the classes of all the data that's involved in our system. So this class organization has two instances. CCI is the company that's responsible for the exploitation of the tunnel. And this instance, CCI, is related by the RDF type relation to the class organization. I will show that in more detail now. So this is actually the resource CCI. So we see the URI saying, where's the mouse here? PMSE, and then we use UUIDs to identify all the instances. So actually this is the full URI, or actually the abbreviated URI, this is namespace. So that's the subject. So I abbreviated here, only mentioning the 4 first characters of the UUID. Then you see here the RDF type, and here PMS organization. So I think everyone will recognize this as a triple. But there's also another triple shown in our pop-up box, and that's the name relation. So again, we have PMSI, and then the URI identifying it, that has name relation, which is in our own PMS namespace, and the name CCI, and it's a data stream. So I think that everyone can follow this. I hope. I don't see people nodding or sleeping. What makes our system, I think, a little bit special is the use of named graphs. Of course, there's named graphs also in Virtuoso always, but we use really small graphs. So we almost put every relationship in its own graph. So I'll print that on this side. Those are two different names. So those are names of the graphs that the relationship is in. And this is how I will show plots. So first we have the named graph name, then subject predicate object. So let's look at this has name property a little bit better. So it is stored in the graph 7119, which is also the instance namespace. But actually there's a little bit more data in the graph. So that's here written fully. And we have here again the relationship what it's about. So it has name relationship, predicate, or subject predicate object. On the left we see the graph name, but here's two extra relations. In our interface you can visualize this relationship also. And that looks like this. And here we also see subject, predicate, object, and these are identical. So this subject is here, predicate, object. But what we also show here is, here's a graph name as a title, but this is the metadata that's contained. So we have, for every relation in the system, we say who made it. So in this example, it's a bootstrap we performed, and creation date. So every relationship has metadata. And the nice thing about this graph structure is that this is a relationship inside the graph, but we can make new claims about this graph, so about this relationship. So I can show it like this. This is this subject predicate object relation, but because the relationship has a name, we can do claims about the relationship, but this can go on forever. So it's really self-referencing. Okay, so what was this approach based on? There's this ISO norm being developed right now, the ISO 15926. This is part 11, which is close, more or less describing precisely how we are modeling data. And this is a picture from this ISO part, which actually looks a lot like our popper box. So we have a graph name. Here in this example, it's modeling a car. And this statement is saying that what the power usage for the power performance of the car is. So we have 3 inches of the car, the power of my car, as magnitude, so 140. Also, again, the same metadata creator in the beginning. Okay, so let's jump back a little bit how this part of the system works. At the end, we have to generate invoices, and it goes in those steps. We do a Spark query to get data from the quad store by this service, the VE service, that produces XML files. Then we present that to a VE module, and we did it like this because we didn't make this VE module, and it needs XML as input. And then it generates a PDF version of this invoice. So I will show how the Spark query is built up. So again, we define some namespaces that we use, the XSD, we have RDF and RDFS, and the PMS and PMSI namespaces. And here again we see how important graphs are. So for every link that we follow, we put it in a different graph. So we say instance, for example, we want meldingen, which are in the system, to be handed over to the VE module. So we query for those, and we are interested in some property. And one thing extra that I want to show here is that actually the system is designed that never any data can be deleted or replaced or actually changed. So there's no way to rewrite history, but the active data can be changed by adding new data to it that points to the old one in a replace relation. So you can always follow the complete trace of the values of the data. And you can see that here. When we generate an XML report, we're only interested in the most recent data. So here's a minus, saying that all the matches that are, for example, for the moment graph, that are replaced by a newer one are filtered out. Okay, so we do this query. I could also show that, but I think everyone knows how Virtuoso works and how you can do a query. I have a copy of the Coentunnel data running on my laptop, so I could show some of the active data. Oh, thank you. Don't know what it means, but I'm just
finding it out.
Okay. Well, that's good because this is the final slide.
Okay.
This is the XML file that it delivers. and we hand this over to the VD model. And I think, yeah, so that's what I wanted to show, and I'm interested in your comments on this. Is this special or is it extremely dull? So let me know.
What's to say? Any question? What you're doing, if nobody says it, is called reification in triple speak. So your every triple is, or every edge in a relationship is becoming explicit knowledge, and then you can attach properties to it, like the creation of it. So in principle, the concept is known. And there has been a long discussion about reification. Its benefits there are obvious benefits of reification, and how you could implement it. And the way you have implemented it is for people who really want reification, the way that it's usually done. So it's by kind of using the graph identifier. But what's kind of interesting is what are the consequences of that? So what are your experiences with Virtuoso if you have let's say millions of graphs?
About the reification, what I thought that most of the time meant was simulating triples with new triples. So you introduce triple and then you say the subject of the triple is this, and the predicate of this triple is that. And compared to that, I like the graph structure not because it's efficient, but because it's easy to understand. But that's not the answer. That's
we're doing graphs rather than the reification namespace would certainly be better. It is our belief. So it is also your belief.
Yeah.
I didn't see statement level reification. You didn't show the examples of statement level reification. Where you have subject, object, predicate as is an idea of proposed statement.
But I think the graph itself represents our statement.
Well, there's one statement per graph.
Oh, one statement per graph.
Yeah.
Okay.
Yeah.
I didn't. Okay.
Okay, but that's okay, but
So what are your experiences? My question was, so what happened, how does Virtuoso hold up against the situation where you have so many graphs? Have you ever encountered any issues?
well, actually, there's one problem now because there's a sensor that is flipping all the time, so it's generating instances all the time. So we have one value that has 130 million versions in just 4 months, and it takes we're not really efficient in querying it yet, but it takes an hour, I think. But I think that's not because of the Virtuoso query, but it's because of the thing we do with this query result afterwards.
Okay, because the result is very large.
Yeah, the result is only 30 million. So, but I think that's the only thing I can say about it, because we had a little time to make it perform really well, and we're now doing a second project where we will optimize it. So that's.
Does somebody get fined if your system crashes, or is that without them?
I think I have to pass that question to you.
Are there ontologies in this industrial measurement? I mean, you mentioned the ISO standard. Are there ontologies in industrial automation and industrial measurement?
Yes, this ISO standard contains two things. Part is just a description how to use graphs, but the second part is a set of initial upper ontology elements. And this is from the systems engineering. And it's actually the person making it is also in contact with the BIM world, and the Dutch government, I think, is making Coins, and Coins is a standard for sharing data around buildings. And buildings can be also in infrastructure like tunnels. And they are trying to find the upper ontology that can be used through all the Netherlands.
So did you find it useful? Because what we saw is that you made your own ontology.
Well, yeah, this is so this new points topology is not yet there. So we have to pick a subset of that, but we have done that by talking to this guy who is or a group of people that is making it. But what we actually do, and I'm not sure if you are going to like this, but we really work in a closed system. So we manage the ontology within the closed system, and we're not expecting to open it up for the open world yet. So even if there's a really big system like the Coentunnel that is built, then all the companies that are asked to work with that, they are still in a closed world situation where there's one library manager.
Actually, I do think it's rather beneficial for linked data to have business adoption for it as well, rather than just linked open data. So I do think that that's a good thing. But what I was wondering was whether the URIs that have been made up by the prefix and the UUIDs, do they resolve to pages or?
No.
No. Okay.
They're just used as a unique identifier.
Yeah.
But yeah, there's no reasoners active, and there's no, let's say, clever data integration happening. It's a little bit the opposite way. So we have defined an upper ontology and also a little bit a lower ontology, and only based on that, new instances can be made. So it's not the other way around. We don't begin with instances that try to match into an ontology, but the ontology completely drives the data creation. So,
Okay.
So what do you think? Is this acceptable?
Well, I mean, I think it is interesting. So you have decided to use RDF because you want, in fact, you want very fine-grained version.
Yeah.
That's what you want. It's very interesting reason to do that. But it would have been good for us if you would have, I mean, what the follow-up questions are, yeah, what are the consequences to this for query plans? So if you go this way, do you hit any deep technical, or do you see that certain queries are very slow? I can believe that the one where you have 430 million versions is going to be slow. I actually recommend throwing some triples away there.
Yes,
okay.
yeah, we will maybe try to do it, but that's actually, it's somehow not allowed because we have to keep track of all the data. That's the whole point of the system.
Do you want a meeting where there could be some discussion of your implementation? Do you want to review with some of us in it?
Maybe at some point, but I don't know if today.
I mean, right now it's not appropriate.
Okay, sorry. Okay, I see there's one question there.
Yes, I saw your sparkler queries and you use minus. Why do you need minus in the sparkler query? You say minus graph something. So what is the? I mean, is this a way to handle archiving and to handle the loaded versions of the triples?
Yeah. So we have this moment ID has value moment pattern, but it's possible that this graph containing this value has been replaced by a new value. So a new graph containing a relationship having the same moment ID, the same hash value relation, but another value. Because we don't throw data away, but we add new data, saying that this new data replaces the old one. So we have this whole chain. But if we query on this complete data set, then we get multiple matches. So we get matches with the actual value, but also with the old value. So we have to, let's say, deselect all the matches that have been.
So the amplification, which explicitly is a very costly operation. Minus can be very costly.
Yeah, I agree. But
okay, this is what I thank you.
You could have modeled it differently, of course. If you are mostly querying the last version, then you could have modeled it differently.
But the problem is that we're not allowed to change the content of the graph.
one must never believe. So you can say this is no longer valid, but you cannot say that this is
But who said?
Yeah.
Your contract.
Yes.
When I make my presentation, I try to remember to say something about how we keep histographs and how we use verification for that, and the whole idea of copies. It is time to get.
Okay, let's take the speaker. I've learned how wicked our government is. Not only do they find you continuously when you're driving through there, but when the tunnel is not operating, you still find you. I have to